Bismillahirrahmanirrahim. Assalamu alaikum. My name is Rafan Walbajwa and I am from the Department of BS Chemistry and my ID is 007. Today, the topic of presentation that I'm going to discuss is reactive dyes. So let's have a look on the contents of presentation, which includes the introduction of reactive dyes. Second one is the history of reactive dye development. Third one is the reactive system. And next one is classification of reactive dyes, in which we further study the classification based on chemical constituents. The second one, application methods of temperature. Fifth one is classification of reactive dyes based on reaction types. Further, this includes two types: dyes reacting through the nucleophilic substitution reaction, and the second one is the dyes reacting through the nucleophilic addition reaction. So sixth one, is the vinyl sulfone reactive dyes, which in which we further study is their introduction, their reaction with the cellulose, and their synthesis mechanisms. And next are the monochlorotriazine MCT reactive dyes. Further, we will study their introduction, reaction with cellulose, and then synthesis. And the last one is the bifunctional reactive dyes. We will study their introduction, classification, which are further classified into homofunctional or heterofunctional, their reaction with the cellulose, and at last we will see the synthesis mechanism of bifunctional reactive dyes. So move on to the first topic, that is the introduction. So reactive dyes may be defined as chromophores which contain pendant groups capable of forming covalent bonds with nucleophilic sites in the fibrous substrate. So reactive dyes contain reactive systems that react with the cellulose or other dyeing material. So providing these covalent bonds are stable to conditions encountered in laundering, the wash fastness properties of the coloration will be outstanding. Unlike other dye classes used on cellulose substrate, the reactive dyes cover a wide range of shade, ranging from black to vibrant, brilliant shades, accounting for their earlier commercial success in the area of dyeing. So the next, moving toward the history of reactive dye development. So the pioneer work of Cross and Bevan was probably the first attempt to produce a dye fiber covalent bond and thus achieving dyes of very high wet fastness. So there's a earlier study were directed to producing a covalent bond between the dye and the fiber or the cellulose material. The driving force for this achievement come from the application of the direct dyes on cotton and viscose that has very modest wet fastness properties of coloration. So cross-beaven pre-treated cotton and benzoyl chloride, then nitrated the benzoyl ester, reduced the nitro groups to amine, diazotized the amine residues, and coupled them to 2-naphthol, producing the orange coloration that was resistant to very severe washing conditions. So the overall reaction of cross and beaven is summarized into the following reactions. So let's have a look on the reaction chemistry. So first, the first step is the reaction of the cellulose material with the alkali sodium hydroxide, in which the cellulosate ion is sodium cellulosate ion is formed, anion is formed. So in the second step, sodium cellulosate anion is treated with the benzyl chloride. That will result in the benzyl ester formation. So then the benzyl ester is nitrated by reacting with HNO3 nitric acid, and then the compound resulted is reduced to amine, as this one. Then amine is diazotized. A diazotized compound is such a compound in which the nitrogen is doubly bonded to another nitrogen atom. So the amine is diazotized and then coupled with 2-naphthol to form the reactive dye. That was the first pioneer work of Cross and Bevan in the reactive dye development. So moving toward the next topic, that is the reactive systems. So the characteristic features of a typical reactive dye molecule includes first one is the chromogen that contribute the color to the dye, and much of the substantivity for the fiber, and as encountered in most other application classes of textile dyes. These chromogens typically belong to the azo compounds, carbonyl, or phthalocyanine chemical classes. And the second one is the reactive system. So the reactive system is that part of the dye that chemically or covalently react with the substrate, that is the cellulose, and often also contribute some substantivity. The third one is the bridging group that links the reactive system with the color carrying part of the dye, that is a chromogen, and it may influence on the reactivity, stability, and substantivity of the dye. And the fourth one is the solubilizing group, which usually is in the form of sulfonic acid substituents on the aryl rings of the chromogen. So here is a schematic diagram of the reactive systems of reactive dye. So the reactive dye consists of four parts. First one is the chromogen that give color to the that gives color to the dye, and the second one is the fiber reactive group, or the reactive system that is bridged or linked, that is linked to the chromogen through the bridging group, and the fourth one is the solubilizing group that that make the soluble in the water. So we have a real-time example here. So this is an example of reactive dye which belongs to the triazenyl compound. So the chemical name of this reactive dye is reactive blue 109. So this one is the reactive group, dichlorotriazine, and the amine group is the bridging group in this example, and this one is the chromogen that gives the color to the dye, and these are the solubilizing these are the solubilizing group that would solubilize the dye in the solution. So moving towards the classification of reactive dyes, so reactive dyes are classified based on the chemical constitution into the following types. First one is the chlorotriazine dyes. The second one is the vinyl sulfone dyes. Third one is the heterocyclic halogen containing dyes. These are the pyrimidine dyes containing halogen groups. And fourth one is the mixed dyes, which includes monochlorotriazine and vinyl sulfone mixed dyes, or the bifunctional dyes or polyfunctional dyes. So again, depending on application methods of temperature, reactive dyes are also classified into three classes. First one is the cold brand reactive dye. This type of reactive dye is applied at low temperature and low alkali treatment, that is room temperature. They are highly reactive with fiber at this temperature. This includes the precune M dyes that are dichlorotriazine dyes. So second one is the hot brand reactive dye. This type of dye is applied at medium temperature around 60 degrees Celsius and severe alkali treatment. So these are the precune H dyes belonging to the class of monochlorotriazine dyes. So they have less reactivity with fiber. And the third one is the high exhaust brand reactive dyes. This type of dye has very low reactivity properties with fiber as against the reactivity with cold and hot brand reactive dyes. And these dyes react with the substrate or the fiber at about 80 to 90 degrees Celsius. So again, coming towards the classification of reactive dyes based on the reaction types. Based on reaction type, okay, the reactive dyes are classified into the following two classes. The first one is the dyes that react through the nucleophilic substitution reaction, and the second one is the dyes that react through nucleophilic addition reaction. So we will discuss one by one. First of all, the dyes reacting through the nucleophilic substitution reaction. So triazine-based reactive dyes groups react through the nucleophilic substitution reaction. So they are mostly chlorotriazines of either dichloro or monochloro type. The reactivity of dichlorotriazine-based dyes is higher than the monochloro dyes is because they contain two chlorine atoms that have greater electronegativity effect and produces strong nucleophiles that have greater reactivity. So they require less temperature and mild alkali treatment for their application compared to the monochloro dyes. They are also known as cold brand reactive dyes. The trade name of some cold brand reactive dyes are Rectofix, Rectofix M, Precune M, and Precune MX. These are the trade names for the triazine dyes. So the general chemical structure of these dyes is shown in the figure that is. So this one is a triazine system, and these are the chlorine substituents that are attached to the diazine system. And this one is the bridging group, and this is the chromogen or the dye part. So a typical triazine system looks like such a structure. So now we will study the reaction of dichlorotriazine with cellulose. So first of all, we have a dichlorotriazyl dye that reacts with the cellulosate anionic fiber, as I told in the previous session. So the conditions required for this reaction are the pH should be 8.5 and the temperature range should be 40 to 50 degrees Celsius. In the first step, the chlorine atom attached to the 2,4-dichlorotriazine is replaced by the sodium ion on the hydroxyl group, as shown in this figure. The two chlorine atoms are replaced by this sodium cation. So the dye is attached to the cellulosic fiber. So monochromatic triazine dyes require a higher temperature and a stronger alkali application than the dichlorotriazine based dyes, because they have only one chlorine atom, as I told in the previous session. The general structure of monochlorotriazine based hot brand reactive dye is present in this figure. So this is the general structure of the monochlorotriazine based dyes. So the reaction of triazine dyes with cellulose is shown in the next diagram. The chlorine of the triazine ring is replaced by the cellulosate ion. Thus, the dyes form a covalent bond with the fiber, which accounts for the high wash fastness of reactive dyes. So in this one is the monochlorotriazine dye that reacts with the cellulosate ion after the treatment of alkali sodium hydroxide. The cellulose is converted into cellulosate ion that reacts with the MCT dye and replaces the chlorine atom and gets equivalently attached to the dye. In the reaction, there are two processes taking place. First reaction is the covalent bond that is formed between the dye and the substrate, that is the cellulose, and the second reaction is the hydrolysis of the dye. The reactive dyes can react with water molecule as well. The reaction of dyes with water is called hydrolysis. So the hydrolyzed dye lose their power to react with the fiber. These dyes remain closely held on the fiber, and if not properly removed through thorough soaping, they deteriorate the wash fastness of the dyes. The nature of the electrolyte used in the solution and used in the solution will have an important role in the absorption of hydrolyzed dye. So this is the reaction that shows the hydrolyzation of the dye. So this one is the 2,4-dichlorotriazine dye that reacts with sodium hydroxide and the hydroxide ion, and the hydroxide ion replaces the chlorine ion and hydrolyze the dye. The dye become the dye lose the affinity, lose the power to attract or bind with the cellulose. And the second type is the dyes reacting through the nucleophilic addition reaction. So the majority of the dyes that react through nucleophilic addition reactions are based on vinyl sulfone. The general formula of vinyl sulfone is shown such as this one. They are marketed in the soluble form, that is beta hydroxyethylene sulfones derivatives, where D stands for dichromophore, that gives color to the dye, and they are sold under the trade name of Ramazole. Basically, with vinyl sulfone dyes are masked in the beta hydroxyethyl sulfone derivatives, and they are treated with alkali before treatment to the cellulose. So they react with the alkali sodium hydroxide and are converted into vinyl sulfone, the reactive system for the nucleophilic addition reaction. And this one is the reaction of the vinyl sulfone dye with the cellulose. The vinyl system act as the reactive system and replaces the hydroxide ion to the cellulose and gets attached to the cellulose. So this is all from my side.